One of the convenient and time-saving features of CodeIgniter is a loose implementation of the active record design pattern. When I use CodeIgniter's active records, I don't need to create classes to connect to each database table, but I should create a model for each database table, and I can use active records to make the models perform database operations. This system is database agnostic, meaning all the query syntax is generated automatically. I can access CodeIgniter's database using this DB, followed by commands such as insert, update, and delete. Rather than explicitly breaking down each command, I'll demonstrate by example by updating the models to allow them to be persistent. I'm also going to extend the bare minimum native CodeIgniter model class to be more functional by adding generic CRUD functionality to it. This approach will also demonstrate how to extend CoreIgniter functionality. If I wanted to generically extend a CodeIgniter class, a specific naming convention is required. Instead of CI_, use MY_. I'll switch to NetBeans and navigate to the core folder. I'm going to extend the CI model class, so I'll create a new file named my_model.php. Class my_model extends CI model. Now, your initial reaction may be to make this class abstract. I'll be honest, that's what I wanted to do first, but CodeIgniter instantiates these classes and abstract classes can't be instantiated. Therefore, it'll just have generic functionality that won't work until it's extended. I'll start by adding a constant containing the name of the database table that'll store records of a given model. This is very helpful for organization and documentation as well. I'll have to set a value, so I'll just make it abstract and just override it. I'll define a second constant containing the primary key for the table. Const db table_pk equals abstract. Next, I'm going to create the four CRUD methods. I'll start with create, which will be an insert method. I'll make it private, as I'm going to have a more unifying save method that will determine whether to call insert or update. As in documentation, create record. I'm going to use this DB to access active record, then the method insert, which takes two arguments. The name of the table, then question as a string, and then the object containing the arguments that map to table columns that will be written, which will just be this. The insert operation will not manually populate anything, so I will have to manually populate the model with the insert ID. Fortunately, there's a method for that. This, curly brace, this, db table pk equals this db, and then the method insert id. That's all that's needed. Let's do a more complex one, which is the update method, which I'll also make private so I can call it from the unified save method. Private function update. Give it documentation, update record. This db update takes three arguments. The name of the table to update, which will be this db table, an array or object containing the columns and values to update, which will just be this, and the primary key of the table that will be updated, this db table pk. I'll use the constants defined earlier to make it generic. To prepare for a loading method, I'm going to make a helper that will populate the model from an array or standard class, which will take one argument, a mixed row. So public function populate, and I'll take a row. So populate from an array or standard class, param mixed row. And then for each row as key value, this $key equals value. Next, I'll implement a method for loading a single record from the database into a model that takes one argument. I'll call it public function load, which will take one argument, the ID of the record. Load from the database. Param will be an integer containing the primary key. In this method, I will assign a variable called query to the result of this db get where, which retrieves a standard object with a result. It takes two arguments, which is the table name again, db table, followed by an array of the key value pairs that it will be matched against, which in this case will be just the primary key and the ID I want to look up. This DB table PK assigned to ID. I'll use the previously created populate method to populate the object. So this populate with query row. The final method of CRUD is delete. Public function delete. Delete the current record. This DB delete. The delete method takes the name of the table, this DB table, followed by an array similar to the where statement I used in load. This time, I'll specify the argument containing the primary key using the constant. This DB table PK, this DB table PK. Finally, I'll unset this primary key once the deletion operation has occurred, as the record won't exist anymore. Now that I have the full CRUD functionality defined, let's make a public method for saving that will decide whether to insert or update. Public function save. Save the record. If is set this, the primary key, use the update method, this update. Otherwise, it's an insert. The final piece of common functionality that I'll implement is an unfiltered get, which will retrieve all records from a model's database table. I'll include optional support for a limit and offset, which will be useful if I ever implemented pagination. I'll start with documentation. Get an array of models with an optional limit offset. Param int limit, which will be optional. Param int offset, optional, but if it's set, requires limit. It'll return an array of models populated by database keyed by the primary key. Then public function get with a limit defaulting to 0 and an offset also defaulting to 0. So if there is a limit, I'm going to assign query to this DB get, which takes the name of the table, this DB table, and an optional limit and offset. Limit, offset. So if there is no limit, query equals this DB get, and then just this DB table, which will return all rows. Now that the query's been performed, let's build the return value. I'll start with an empty array. Ret val equals array. Then get the class of the current model. Get class of this. I can iterate over the query using the method result, which will return database rows. For each query result as row, create a new instance of the current class. So model equals new class. Populate it with a helper function, so model populate with row. Then add it to the return value using the primary key. Ret val row, and then this DB table primary key equals model. The primary key is a nice shortcut if you don't want to use the constant or try to remember what the key name is. Finally, return the ret val. Save the file. This seems like a lot of work, and in some ways it is. However, it also highlights how to extend native CodeIgniter classes and will save me from writing redundant code in my models. Let's give the models full CRUD functionality. Open the publication model. Instead of CI model, we'll extend my model instead. Then I'll add the constants containing the table name, const db table equals publications, and the primary key, const db table pk equals publication underscore ID. Save, then open the issue model. Again, I'll extend my model, const db table equals issues, then const db table pk equals issue ID. Save again. At this point, the models now have full CRUD functionality using CodeIgniter's active record. Let's test it out. Open the magazine controller and navigate to the index method. CodeIgniter requires that models be loaded before they can be used by using load. I'll demonstrate two ways of working with methods, one by using this and the other by instantiation. I'll start by creating the publication. So this load model, which just has one argument, the name of the model, which will be publication. When a model is loaded, the model is made available through this using the class name as the property name. I'm going to set the publication name using this. So this publication underscore name equals Sandy Shore. That's all I need to create the record, so I'll save it. This publication save. Let's see the result by dumping the model. Echo tt pre var export this publication true. I'll close the pre and the tt. After I've created the publication, I'll create a new issue. Same as before, I'll use load to get the model. This load model. The model's name is issue. However, this time I'll instantiate a new issue model and assign it to a variable. If I didn't use this load, the class would not be found. Issue equals new issue. I'll set the publication ID from the publication model. Issue publication ID equals this publication ID. I'm going to set the issue number to 2. Issue number equals 2. And I'll set the date of the publication using PHP's date for February 1st, 2013. Issue date publication equals date 2013-02-01. CodeIgniter is going to handle the conversion to MySQL's date format, which is time-saving. When I'm done, I'll save the issue. Issue, save, and then debug the result. I'm just going to copy and paste that from above, and var export issue true. Save the controller, then return to the browser, and refresh. I can see two models. The first containing publication ID number 1 named Sandy Shore, and then issue ID number 1 with publication ID number 1, an issue number set as 2, and the date publication. Note that the issue cover, which I didn't set, is still null. We'll set the cover later in the course. This way of looking at magazine back issues works, technically I guess, but is this really nice to look at? Instead of dumping the result, let's format it cleanly.